Welcome back. In this segment, we'll talk about the image classification, and specifically, we'll talk about unsupervised and supervised classification. Since this is a very important topic, this video will cover both of those segments. So let's get right to the script. This first script you are seeing is a combination of unsupervised classification on the top and supervised classification in the bottom. And first we start with line 5 in the script where I highlighted here from line 5 to line 9, that is the study area of this example script that we will be using. And then on line 12 to 17, this should not be new if you have watched our previous image collection tutorial video. This is simply just extracting an image out of the Landsat 5 collection and create an image mosaic based on that collection. And then line 20 to 23, that's displaying and centering the map down below for the Landsat 5 image we are trying to analyze for unsupervised classification. The actual unsupervised classification code starts on 27, as what I'm highlighting here from 27 to 31. This is simply creating a pixel samples out of the image, the Landsat 5 image we are using in this example, and the computer will extract all of those pixels and try to make sense of all of those pixels through its automatic algorithm. And in the example, we use this Weka means algorithm. And obviously, there are different types of unsupervised classification algorithms out there. And the example that you can look at is in the doc tab, as I've showed you before. So if you just open up the left panel here, under the document tab, up on the left, there where my cursor is, you can be able to find the various unsupervised classifier to use. So just going back to the script, on line 34 where I highlighted the Weka mean, this is one of the example of unsupervised classifier, as I mentioned before. This 3 number I have there in the parentheses of Weka means is signifying that there are 3 classes that I wanted to classify out of the pixels that I gave it to train. You can obviously assign different numbers. If you think your image have, say, 10 different classes, then you can simply just put the number 10 in there for it to train. And then following the script here on line 37, as you can see, it is trying to create a cluster out of those pixels. So trying to identify if there are any patterns in those pixels for it to be able to classify. And the input here, as I'm highlighting on line 37, this is simply just the Landsat 5 image that we are using to be able to classify the image. Then going forward here on line 40, we are going to display this classified image, and we call it as the classified image, as you see there, where I'm highlighting on the screen there. And the way we are displaying this is simply using this random visualizer, which where I'm highlighting on line 40. There, this is simply just assigning a different color to the three classes that we are going to classify it to. And let's just run the script and we'll look at the result. So after I hit the run on the top, we'll open up the map down below so we can see the result. So first we look at, there are two different layers. As you can see, in the first layer is the input image, and the second layer is the classified image, as what you're seeing on the screen there. So let me just show you the inputs image real quick. So this is a very dark Landsat 5 scene. And let me just show you real quick to be able to just make it much more brighter and clear to show you. I simply just shortened the band minimum and maximum values, and this was covered in a previous image display tutorial. With Landsat 5 scene. And the reason why it's red, as covered before, it's because it's an infrared and the red, so the color infrared combination. And the vegetations you are seeing are showing as the red color there. So after we classify this image, we saw it earlier, and you will be seeing an image that looks like this. And as you can see on the screen there, it has three different colors as what we specify it to be, three different classes. And in this case, so let me just turn off those dots here. And when we zoom in on the screen, as you can see there, there are different classes associated with it. And in this case, so let me just go back to this image. The computer doesn't know there are three different distinctive classes. So the computer just randomly puts out these three different classes based on the number of classes we told it to be. So a user then will use this map and go in and classify these three different classes. So when we look at this image, you see the green area. If I zoom in area real quick. So the green area, if we just focus on areas, for example, like around this area where my mouse is, it's technically going to be a class of its own. And if we just change the transparency, you can sort of see the green color is something to do with the railroad, the roads down there, as you can see there. And then the other color we're seeing is this kind of yellowish color, and it's very close and nearby to these roads. And when we kind of turn this off, we'll be able to see this kind of is some sort of grass area in between the other land cover areas. So the third class, which is demonstrated in this pinkish color, and when we turn that off, we're able to see these are clear forests that are demonstrated as the pink color class there. So then in a specific use example, someone would just go into this map that was classified unsupervised and then pick out those areas and say, okay, this class is going to be trees, and the other color or the other class is going to be the other, such as forests or roads or impervious surface, so on and so forth. And as you can see on this example, it's not that clear. So it's not going to be 100% accurate in terms of the image classification. So in order to get a better image classification, we have to use another approach. And this approach takes a little bit more work and a little bit more manual work, to be exact. And it's called the the supervised classification approach. And let's get right to that example. So I'm just commenting out this so we can move on to the second part. So the other approach, supervised classification, we start from line 50 all the way to, I believe, the line 63. So what I'm just highlighting here, this is simply as we did before, bring in a study area and be able to display that image we are trying to classify. And then on line 66 to 69, we're simply just displaying it as we always did before. So the actual supervised classification code starts on line 71. And I have what I'm highlighting here, this chunk of text there. You don't necessarily have to read them, but simply it's telling you one of the fundamental steps in supervised classification is you are telling the computer what pixel is what class. And obviously you don't have to tell all of the pixels inside that Landsat photo or any other image. You can simply just pick and choose, the image classes that you know are one class. And this is a very fundamental part of this supervised classification approach. And I'm just gonna simply show you how you can do it in Earth Engine here. As I open up the map, so as you can see, so I'm just gonna open up the entire map so it's easier to do that. So now you can see the initial Landsat image there on the screen. And so in order to classify these manually, you have to create a new layer inside of this panel, as you can see the geometric imports. And I have collected two different layers. So one is the vegetation training example, and then the other one is the non-vegetation training example. These are already done. So as you can see, there are dots on the map. Apologies, the red on red isn't very clear. Let me just change that to a different color so it's easier for you to see. Okay. So these place markers, as you can see, these are areas that I simply just dropped to tell the computer the pixel at that location is either vegetation class, which is the blue colored place markers you're seeing there, and then the non-vegetation are these green place markers, which signifies the non-vegetated pixels. So once we just create these features, we can go into this tab or this highlighted area as I'm clicking on there, and you can click this gear icon, and then a menu will pop up as you can see on the screen there. You can name this layer to whatever you want it to be. So in this example, I named it as vegetated training class. And then you can also give it a color, as I showed earlier very quickly. And you can just click on this color ramp, and the color will be changed for specific use. And one very important thing I want to emphasize here in the drop-down menu here, there are different options in there, and you be sure you should check this feature collection option, because once you click this feature collection option, it will be able to give you this property and value options. And in there, you can specify the class value. So in this case, we assigned the vegetation training class as 1, which is this 1 value down here. And if we open up the non-vegetation training class, so I'm going to just close this by clicking OK. And when we open the non-vegetation training class, and we zoom in onto this panel again, you'll be able to see the class value for this non-vegetation is 0. So this is a very simple way of doing 2 classes training. Here we have a non-vegetated class and also a vegetated class. But if you have other classes, you can do change those 1 and 0s to other numbers, so like 1, 2, 3, 4, 5, 6, as so on and so forth. So that's in a summary how you can manually train these classes to prepare the data for supervised classification. So next we just continue onto the script here. On line 80, we merge the 2 manually trained feature collections to create a larger training class. And in this training, what I'm highlighting here on line 80, we named this training data set as training. And then starting on line 85 to 89, where I'm highlighting there, this is very similar to what we did with unsupervised training. We are picking the values of the points that we placed on the map earlier, and the computer will be able to collect these training data sets and pick out the pixel values of those image pixels. And this will form a database simply just of the different pixel values of the different bands and be able to associate them for the different classes that we are trying to look at. So from there, we go to line 92. This is going to simply use the training that we just collected and extracted from the image band values. So what I'm highlighting there on line 39 corresponds to the training data set we just established. And in this case, we use the classified image classifier that is called random forest, which is I'm highlighting there on line 92. And this is a classifier very popular among machine learning classification to be able to classify image into different classes. And obviously there are different types of image classifiers that is out there. So be sure to check them out and use them for your own need. In this example, I simply just use random forest because it requires the less amount of parameters. And the parameter we're defining is this 100, as what I'm highlighting on line 92. I am telling it that in the random forest algorithm, please construct 100 different trees, classification trees in this example, and pick out the best classification tree. So just a very brief background on random forest. Obviously, you can read more about it on other sources, but random forest is simply just creating classification trees and creating a whole bunch of them and picking the best classification tree out of those forest, if you will. So many trees creates a forest. And so in this on line 92, we are simply just constructing a random forest classifier to be prepared to classify our image. So on line 96 down below, this is simply how we applied our random forest classifier to classify our input image. And then we will be able to display this result on line 99. So what I'm highlighting there, classified, this is the result coming from the classifier in this case. And let's run this script and we'll look at the map to see how our result comes out to be. So now I hit the run and we're gonna open up the map. And as you can see there, first we recognize there are two different layers on this map. One is the input image and then the other is the classified image. And just to remind you briefly what the original image looks like. So as we seen earlier in the unsupervised example, this is what we are seeing as the original Landsat image, with the red as the vegetation. And we have told it that some of these points, so the dark green place markers, are the forests, and the non-forests are these lighter green color, as you can see on the screen there. So after we gave the computer these information of these dots, the computer automatically classified the image into two different classes. So when we turn on this classified image, you'll be able to see there are two different colors. One is black and one is white. And the white colored pixels signifies the forested or the vegetated pixels in this case. And the black colored pixels are the non-vegetated pixels, so the non-vegetated land cover in this image. And if we zoom into an area, we're just going to show you quickly an example what this looks like. So when we focus on this kind of spider web looking structure there, this obviously this shows us the somewhat the structure of the roads here. And when we turn off the classified image, we can surely see these roads are standing out clearly. So in this case, the image classification is very successful at picking out the non-vegetated areas. And another area I wanted to just show you is perhaps this gray colored impervious land cover area, and when we turn on the classified image, we'll see this area now is non-vegetated class. So this shows us clearly it's very successful at classifying this image into the two image classes that we wanted to classify. And obviously, you can modify this example to your own need for classifying various types of images, not just Landsat, but also like NAPE imageries, so like aerial photos and other satellite imageries, And this is just a very fundamental example I wanted to show you for this segment. And so this is the image classifications. And in the next segment, we'll talk about how you can increase the accuracy of these classifications using the classification accuracy assessment. And I hope to see you there. Thank you.